So, as Malik told you, this is the fifth lecture in the series about futures. This one will draw together the themes that were highlighted in the preceding three lectures, which was a series of surveys of frontiers and horizons in matter, life, and mind, and the first lecture, which outlined a structure where science can lead us to considerations of purpose through the magic triangle of is connecting to could be, connecting to should and shouldn't be. So let me frame this discussion, which brings it all together, by giving the overarching narrative that emerges from our previous three surveys of scientific frontiers and horizons. Over the last century or so, our understanding of matter, life, and mind today have reached qualitatively new levels. For the first time, we really know what those things are, I would claim. So in the case of matter, we have precise equations that can be summarized very compactly, put on the front of a t-shirt as they are here, that when you unpack them, output the world in an algorithmic way. And every experiment that's been done to date is consistent with this very compact description. And it's been extraordinarily fruitful. One application is that it gives you a rational understanding from beautiful mathematical principles of the emergence of the periodic table and the emergence of chemistry with the particular elements we have and their particular properties. In the study of life, we've learned that metabolism can be and important processes of respiration and energy distribution can be understood at a molecular level, and its molecules all the way down. There are no vital forces apart from the forces that already appeared in our understanding of matter. And we've learned also that life has an important information basis, that the code for life is in a form that's almost linguistic and even more like the way information is read into computers. It's a linear code of 4 symbols and registered in DNA. And by reading out this code, the cells can make the proteins they need and regulate all those processes shown on the previous transparency. In the study of mind, we've also learned that it has a material basis. We have very detailed pictures of human brains, and so far, every experiment that's been done is consistent with the hypothesis that Francis Crick called the astonishing hypothesis, that mind emerges from matter, and that's all there is. This is a beautiful image of a human brain painstakingly examined from magnetic resonance studies and laid out flat so its structure can be clearly seen, and it has a structure of columns and a very clear organization. This is a magnificent picture that you can see in greater resolution and also with explanations at this Welcome website. And we've discovered that we can use the understanding of matter to make new kinds of minds. And that's given us insight both into the nature of mind and the nature of information processing that goes on, both naturally and in the context of human endeavors. So this is qualitatively different from the way things were a century ago, let alone 1,000 years ago, and extraordinarily new powers accompany this knowledge. We really have to rethink many things from the ground up. Some of the powers are, we can design matter, we can hope, because we know exactly what the equations are, we can manipulate them using mind tools to make plans for what we can do in the physical world. And in this way, progress is being made on designing catalysts and useful materials and drugs and so forth. This endeavor will reach a new level when we have computers that are adapted to the quantum world, the so-called quantum computers, and these are on the horizon. We also have the power to intervene in the genetic material now with precision and delicacy, thanks especially to the CRISPR technology. And we have powerful brain-inspired ways of information processing that now can perform some of the feats that were difficult to do for previous generations of computing based on command structures. These neural nets learn much more like human brains do. They were inspired by human brains and are giving insight into how human brains work. It's a two-way traffic of ideas. So that's the new situation. And it poses the question, what's next going forward? What could happen and what should happen? Which brings us to today's lecture about scenarios. I'll be discussing possibilities and the choices that they offer. So, possibilities first. The conquest of happiness due to increase in the wealth of humanity was already anticipated and celebrated in 1928 by the great economist John Maynard Keynes in an essay called The Economic Possibilities for Our Grandchildren, where he said, and remember, this is 1928, for the first time, so it was the beginning of these great developments, just the prehistory almost. Thus, for the first time since his creation, man will be faced with his permanent problem, how to use his freedom from pressing economic cares, how to occupy the leisure which science and compound interest will have won for him to live wisely and agreeably and well. Since then, this fantastic growth in wealth has continued and, in fact, accelerated. Now, what Keynes had in mind for living agreeably and well probably was something like the Bloomsbury Group, to which he belonged, a group of civilized, accomplished people who like to create works of art, create literature, do economics. There was a ballerina involved, and it was very civilized, very British. But other people have other ideas. There are some more ecstatic activities, also somehow more physical activities where people get the runner's high and also challenge themselves, or ecstatic activities in crowds. This is a music festival at Albert Hall, not so far from the Bloomsbury Group. But also you can imagine similar pictures at sporting events or political rallies. Another source of ecstatic events is drugs. Now, this is methamphetamine, and this kind of ecstasy comes at a price, but with better understanding of how brains work and how molecules work, these kinds of ecstasy, which at bottom are chemical processes, will be safe and a choice. A remarkable development that's open-ended and thrilling is that technology can bring you into new worlds of imagination. So here is someone doing something. It's not clear what they're doing or why, but we can imagine, and she can imagine. She can dial up what she wants. What is she experiencing? Well, you can conjecture. Let me show you some conjectures. Well, maybe she's enjoying a holiday in a warm climate, feeling the surf on her feet and legs, and with a friend. Maybe she's flying through the Sistine Chapel and admiring the great works of art. Or maybe she's inhabiting one of the kinds of the places that people dreamed up as utopias, and often, well, these days put into computer games. So the possibility for passive enjoyment or self-contained enjoyment, I think, are quite compelling. Those things will happen. They'll get better and better. There'll be more and more immersive experiments. There'll be better ways of stimulating safer ways of stimulating the brain's reward systems and so forth. But there will also be, I hope, and I think there better be, restless spirits who want to look also and look out and interact with the external world and have intellectual adventures and do things that haven't been done before. For those spirits, for restless spirits, there are great questions, great adventures, and big problems that are opening up because of these developments. And there had better be some, because this la-la land of passive enjoyment is not sustainable. Computers break, grids break down, and so forth. So we'll see that there are great questions, great challenges involved in keeping it going. So one thing for restless spirits to occupy themselves with are great questions. Great answers have led to even better questions, more sophisticated, more ambitious questions than we could ask before. What's out there? We've learned that there's a very large part of the universe that, in spite of our profound understanding of matter, we don't understand. There's some stuff out there that's exerting gravitational influence, but is definitely not any of the constituents of matter that we've learned to love and put on our t-shirts and understand fully. These, by mass, in fact, dominate the universe. The part of the universe by mass that we understand is only about 4%. So it's only 4% that are made out of the kinds of atoms and photons, electrons, gluons, and quarks, ultimately, that we are made out of and that are the subject of the bulk of our science, including all forms of engineering. So what is it? We don't know. That's a great question. Recently, looking on a slightly smaller scale, people have found planets. There are now thousands of planets. This chart was the full census as of 2015. There were 500. Now there are over 2,000 exoplanets of different densities and temperatures. If you look at this website to see the explanation, the full explanation of the chart, this is not an artist's impression or fantasy. This is actual data made into a beautiful presentation. Then this is the discovery of new planets. Some of them could be hospitable to different kinds of life. This one, well, these 500 include the 9 of the solar system. Pluto is here also. This one is Jupiter. And you see Jupiter is, of course, the giant of our solar system, but there are bigger planets out there. And that one that you can barely see is Earth. And Earth-like planets are also very well represented. In fact, more represented fractionally than is reflected in this picture, because they're harder to find than the really big planets or the really hot planets. But there are plenty of them. Getting closer to home, there are wonderful things to explore within the solar system. This is Europa, a moon of Saturn that contains oceans beneath a frozen crust, and also might be an abode for some kind of life. And in any case, it's an extraordinarily interesting object. And look, we've already managed to get close enough to take nice pictures and actual visits are not that far off. Within the Earth too, especially in the oceans, there are unknown or underexplored places, including recently discovered thermal vents, where hot gas comes out boiling up through the ocean floor. These are the abode of really weird creatures, giant worms, and are potentially are also thought to be potentially one of the places where life might have started. So that's one kind of question. What's out there? Another kind of grand question is, what happened? How did it get this way? This is an iconic picture of the universe taken in the microwave region of the electromagnetic spectrum. This is a picture whose contrast has been turned up by about 10,000. The actual picture is sort of very, very dull. But if you turn up the contrast by 10,000, you start to see structure. These are the imprints of fluctuations in the early universe that grow into all the structures that we see today. This has tells us a lot about the early universe, this sort of picture of what the universe looked like about 100,000 years after its birth. The light since then from here turned into microwaves has propagated freely. So this is like a snapshot of what the universe was like then. It's an extraordinary feat to have measured this, but we're not done yet. With greater accuracy and also measuring more properties of the light, particularly its polarization, we'll get additional information about the very, very early universe, maybe imprints from gravitational waves, which let us see even further back into the well within the first second of the lifetime of the universe. In fact, in theoretical models, it's more like the first 10 to the minus 44th second of the history of the universe. In case those signals aren't big enough, a grand project is to view the gravitational wave background in solar system size scale observatories suited to their wavelength. This is the proposed LISA project that'll happen eventually. Theoretically, there are plausible ideas that suggest that the universe that emerged, that we're within, emerged from our Big Bang, is not the end of the story, that there could be more Big Bangs, there were more Big Bangs, and we don't know if this is true. We don't have a really secure theory, but this is certainly an exciting possibility, and some consequences have been suggested that could be signals of this kind of structure. So each of these bubbles is a whole of what we would call a universe. We also don't know about the origin of life. We also don't know about the origin of mind. A hero of modern science, whose name has come up several times in these lectures, Richard Feynman, famously said, well, famously to me at least, said, what I cannot create, I do not understand. In his office at Caltech, he had a blackboard where he kept a few key quotations that he found inspiring there for years. And this was one of them. In the upper left-hand corner, he had scrolled, what I cannot create, I do not understand. We can read this the other way too, that if we're going to understand how things came about, the origin of life, the origin of the structure, the universe, and we will have to acquire the ability to create those things. So the acid test of whether you understand the origin of life is, can you reproduce it? The acid test of whether you understand the origin of the universe is, can you do it again? And that's the ultimate grand challenge posed by these questions. So besides answering intellectual questions and having these kinds of intellectual adventures, there are adventures of a more traditional kind that these newfound abilities make plausible, make feasible. One is living underwater. This might be something we need to do if climate change continues, and would certainly be a great adventure. Another is escaping this. So that would be escaping the limitations of our species to land. But we could also imagine going up on the space elevator, which I've described previously. And this is a question of building strong enough materials. Probably human bodies are not the ideal mechanisms to reach out and touch the universe. They're fragile. They're adapted to a very narrow range of conditions that we find in our biosphere. But we can send out ambassadors of this kind that will report to us and be better, more native to the hostile environments that we want to explore. Ultimately, if we based on profound understanding, we can bring the ideas of biology, of self-replication with reproduction, into engineering practice on a large scale. It makes it quite feasible that we could have a self-replicating swarm of robots that over the course of a blink of an eye on evolutionary or cosmic scales would be able to move out through the whole galaxy and seed it, if you want, explore it, seed it, extend, you might say, the dreams of imperialism to a galactic scale. Now, besides these adventures, intellectual and physical, there are many big problems that have to be addressed. Each of these could easily be the subject of a whole lecture series, and they're widely discussed, so I will only sort of mention them, go through them very briefly. One is keeping the Earth habitable. Infamously, are the results of our industrial activities, and particularly burning fossil fuels, is to produce byproducts, carbon dioxide in particular, that's making the Earth warm up much faster than animals and the ecosystem and our civilization can catch up with. Cities are threatened, which are mostly built on coastlines because they're generally ports in their origin, are going to go under. And there was just the other day, I think yesterday or the day before, the release of the latest IPCC, International Panel on Climate Change, report to the UN, and it's very alarming. The response to the challenge of global warming that has been mounted is not adequate to the problem and is not living up to the promises of the signatories of earlier agreements. Now, an underlying cause of this problem is that people want energy. The kind of growth in per capita wealth that was advertised before, and the promise of the conquest of happiness that it brings depends on having lots of energy per person. And know how to do it. We're beginning to know, we know how to produce, to get lots of energy, to derive it from the sun and from nuclear energy in ways that could be abundant and are increasingly becoming cheap and clean. But there are certainly big challenges in making that into a scalable technology and replacing the current carbon-based technologies. Similarly, making nutrition cheap, clean, and abundant, eradicating diseases, and especially the queen of diseases, if you like, which is aging. Young people have a very much lower death rate by any kind of disease than older people, and so and many diseases are really characteristic of or byproducts of the general aging process. So tackling that should be an application, a most important application of our profound understanding and empowerment. Plague proofing is another great project. Bill Gates recently wrote an op-ed in the New York Times proposing concretely steps that could help to plague-proof the world from mass infections. This would be not only for people, but also plagues infect important crops, important animals. It's a beautiful challenge, actually, to our information gathering and transmission systems around the world to detect early on these issues. So, and by doing things like monitoring sewage, where all kinds of microbes wind up very early, one can catch these things early on. And if you're ready with the appropriate technologies, which are also being developed, mRNA and other technologies to combat viruses and microbes that produce plagues, we can go far in plague-proofing the world. All that would not have saved the dinosaurs who got hit by a meteor, but that one we can also address. And in fact, fairly recently, there was a dramatic step in that direction, the so-called DART mission of NASA, where they slammed a satellite into an asteroid to see if they could nudge it or how well the asteroid responded to that collision. And it was a great success. You see, there was an impact. Last September, you can see how happy the people are to see their satellite destroyed. It gave a lot of information and showed that you could hit a target like that. And someday that might be a very, very welcome capability. But in case that fails, and or in case there are other natural disasters that are predictable, not in detail, but predictable that they will happen over the course of 100,000 years or so, great volcanoes, great earthquakes, that would put a severe pressure on human civilization, not to mention the possibility of unnatural disasters where humans set off, use their power to launch nuclear warfare and create great destruction. We should have, and I think this is an understudied question, we should have ways of preserving the progress that we've made, both the information and also the genetic codes of humans and other useful creatures, so that civilization could make a rapid comeback. An extreme form of this was, well, let me just, that's a lot easier than colonizing Mars and would be a lot more effective. A couple of possibilities deserve a special mention. One is that these technologies, CRISPR and the better understanding of basic biological processes, has enabled us to imagine directing our own evolution. And the idea of directing evolution is not a new one. All the dogs you see around us, which come in many, many varieties and have entertained people for centuries now, are all derived from wolves. And they've been derived by directed by selection, by evolution, directed by people. But in recent years, this has become much more sophisticated. The 2018 Nobel Prize in Chemistry was given to Francis Arnold for the discovering or advancing the directed evolution of enzymes. So by applying selection instead of to dog breeds to bacteria, which grow much faster and can be tested chemically, she was able to produce quite a few enzymes that were useful for industrial processes and medical processes. The vision of directed evolution was already envisaged by Olaf Stapledon, as I mentioned in an earlier lecture, and he envisaged the possibility of engineering great brains by evolution, or flying humans. These are all different descendants of people in his vision. These are not things that are necessarily so fictional anymore. These are things that one could imagine developing research programs that lead to in these directions. Oops. This is the Wrath of Khan, where some superhuman people were produced by selective evolution, also known as eugenics, and they were designed to be leaders, and they turned out to be kind of nasty guys. So, Star Trek II, The Wrath of Khan, is a study in why you should be careful about selective evolution, even though that it could be a wonderful thing. It's also a dangerous one. People talk a lot about artificial intelligence and cyborgs and things that make it all seem very horrible and unnatural and weird. And yet, it doesn't have to be. And I think we should talk about instead synthetic intelligence, synthesizing new kinds of intelligence that we can work with and even collaborate with and even ultimately merge with as embodiments of these technological and scientific possibilities. This is a surgeon here in the corner operating in a new kind of way. The surgeon doesn't interact very directly with the patient. The computer, the surgeon is manipulating little controls in a computer console and watching through eyes that are far away, or at least on the other side of the operating room, that are better than his eyes, better magnification, seeing in other regions of the spectrum, and so forth. This is happening now. This is something called the Da Vinci operating machine, and it will take out your gallbladder for you very efficiently, for instance. It inspires a pun, which I'm about to inflict on you. This is cooperation between man and machine. We also have symbiosis, where people design machines which help them in their work. In this case, this young lady is designing a computer and there's a computer helping her in her work. Maybe it's the very same computer or the next generation of the same computer. It's a symbiotic relationship. Who's helping whom here? They're both helping each other. I'm always asked, and I was asked, have been asked here too, many times about the issue of consciousness. Is consciousness something that these entities will have? And I'm certain, morally certain, that the answer is yes. But consciousness is continuous with self-awareness. And what's missing in current neural net designs, and neural nets are the closest embodiment to human brains currently in their architecture and how they operate and their abilities, their perceptual abilities. What's missing in their algorithms is the possibility of feedback. It's very important in the learning algorithms for neural nets that the information only flows in one direction at a time. So you see something, you get a response, you analyze the response, go back and forth and attune things that way in a monotonic way. And that's why learning algorithms, the backpropagation learning algorithm works so well. But self-awareness, and it's also why the neural net can't explain very well what it's doing or what it has accomplished. It can't tell you. It plays chess very well, but it can't tell you why, because it doesn't have any way of looking inside itself. But that is something that makes computation potentially much more efficient. It's probably why it evolved in humans to have, and other animals to have self-awareness, and that can be programmed in. It's going to make the algorithms more complicated, more difficult to implement, but is the next great step, and the necessary step, I think, to get the emergence of something we recognize as consciousness. So probably necessary and sufficient. So the result of all this will be an ecology of minds, different kinds of robots that could be more or less humanoid, as envisaged in the Star Wars universe. Most of them friendly, but not all, as you see here. I recommended to you last time this marvelous book, Clara and the Sun, which is a beautiful humanistic book written from the point of view of an artificial or synthetic intelligence that was created to be a friend and a caregiver for a young woman. And this new intelligence is empathetic and very insightful in some ways, but not in others. And it's a very, very interesting, and I think mind expanding exploration of what happens when you have these kinds of new intelligences. But they don't have to look humanoid. This was HAL in the movie 2001, which was the intelligence of a space mission, and talked even more impressively than ChatGPT, and was able to manipulate things within the spacecraft and control the environment, and all kinds of mayhem ensues. But it's an example of intelligence not in a humanoid form that is also going to be something that emerges in engineering practice. In fact, the Da Vinci robot that allows operations to be done doesn't look like Da Vinci very much. It's not humanoid in any way, shape, or form, but it's adapted to its purpose. I showed you before the speculation, the vision of Olaf Stapledon of the giant brains. Although the giant brains of a biological nature have not been engineered, as I think I've discussed earlier, I think they could be and would be quite interesting because of this repetitive structure of the human neocortex and its rapid evolution, and the fact that it seems to be mostly constrained by the size of the human pelvis in its power, because the baby has to get out. But the development of silicon mines, giant ones, is not a speculation. This is what powers the search engines we take for granted, and the modern internet are gigantic banks of computers. This is one of the largest ones, and of course, you can see that it's a very long corridor. This is only a very small part of the whole thing, which is basically the size of a shopping center, all of which is tiny little transistors, very densely packed, plus the infrastructure to hold them up, and especially to keep them cool, because their activity generates a lot of heat. But the dream of giant brains, although not yet achieved in a biological context, is reality already in the silicon context. And that doesn't look very humanoid either. And yet it'll beat you at chess or Go or any number of games and hold an intelligent conversation now these days. But to me, all these different forms are better thought of in a kind of more worthy way if we think of dynamic displays of information on a grand scale. And this was an experience that I had at the Botanical Gardens here in Arizona, the Bruce Monroe installation, which I keep coming back to, which was this dynamical display on a grand scale of different colors of lights going on and off, and really made me appreciate how complexity can be generated and be dynamical and can be beautiful on a grand scale. So those are possibilities, and I hope you share with me the wonder and the mind-boggledness of what is not anymore speculative. These things, well, when they will happen is speculative, but they might take tens of years in some cases, hundreds in others, thousands of others, but we're not doing dreams of millions of years from now. These are things that are within the ambit of scientific and technological vision. But there are choices to be made. Which of these things, if any, should you do? Why, in particular, hasn't Keynes's vision of a lovely life for everybody come to pass? And there are many, many reasons that could be analyzed. We've had, since 1928, we had a world war, we had lots of lesser wars, we have some ugly business going on at this very day. And we still have poverty in large parts of the world, gross maldistribution of wealth. Why hasn't this benign world of wealth and happiness that Keynes could already envisage based on the wealth available in 1928 come to pass? Well, beneath the characteristically human neocortex that reasons and weighs different alternatives and thinks about comfort and adventure, we have a lizard brain that is bequeathed to us by selfish genes. Selfish genes is really just another way of saying natural selection, things that whose criterion of goodness was not any moral principle, but reproducing themselves. And what people have done in practice with the wealth is make more people, just what their genes would tell them to do. So this was envisaged already by Malthus in essence, in the early 19th century. And as population goes up rapidly in response to improved conditions, it outruns the improved conditions. It's exponential, whereas the improvements in technology, if they're exponential, which in some cases they are, but in many cases they're not, or if they're limited by land, limited by resources, they get outrun by population. And so that's a large part, I think, the deep reason why the paradise has not come to pass yet. A related, but more general form of this insight is that that was put forward in the movie Forbidden Planet, where they have this beautiful idea, an ugly creature that was the monster from the id that destroyed a very advanced civilization that created it. The id, of course, is this lizard brain, whose drives, whose motivations are not philosophical or moral or in terms of making choices about well thought out plans, but simply survival strategies, survival in the generalized sense of producing lots of offspring. And that can lead to aggression, to formation of in-groups and out-groups, and many of the other difficulties that stand in the way of making rational, what we think of as rational choices among the alternatives on offer. So to help the neocortex fight back, education is vitally important, especially to convey the idea that that's called complementarity, that different viewpoints can offer insight that's related to tolerance. I could certainly and have given entire lectures on this beautiful principle that emerges from our deep understanding of the physical world, as well as from sages like F. Scott Fitzgerald, who didn't realize that it had a an important, that was an important guiding principle also in our understanding of the physical world, but that's something we should definitely educate people with. And also in these days when we're surrounded by many Ozymandias figures, we should remind them that the important contributions to human welfare, the important contributions to the lasting and important contributions to the human adventure are not dreams of national grandeur or personal, even less personal grandeur, but the kinds of neocortical choices that we make in our better moments when we know what we're doing. So learning is very important. Learning can, because of our technologies, be on steroids. You can immerse yourself literally in other worlds. You can immerse yourself in the world of quantum mechanics, make yourself into an atom and see like an atom does. You can make it fun by making these things, by making things games. People talk about gamification, but I think the more general thing is funification, making things fun, like collaborating with machines, as we've seen, stimulating by fields, stimulating by drugs, genetic enhancement. All these things are complex, but extraordinarily powerful. And if we're going to collaborate closely with machines, the fact that machine learning is so powerful, can be so fast, can survey such vast amounts of data, and now we know how to encode that data and have the machine learn in very impressive ways. Learning has a chance to catch up with the evolutionary lizard brain that we carry within us. To close, let me go back to my childhood when I grew up in New York and I saw license plates with this strange word, Excelsior. I had no idea what that meant, but I asked, and it means ever upward. And it's a very appropriate motto for New York, but it's also an appropriate motto, I think, for the kind of position we as humanity are in today, where we're faced with such enormous opportunities. And yet, we also see that we haven't reached as far as the opportunities offer by any means. So I come back to this beautiful image of Archaeopteryx, the ancestor of modern birds. Archaeopteryx flew and undoubtedly derived great joy from flying, but it didn't fly very well in retrospect. That's okay. Archaeopteryx was a noble creature, and striving, it suggests, is an end in itself. The possibility of deriving joy from doing things that are new and adventurous, even if they're not ultimately very well done. So let's hope that our children, whether they look like us or are enhanced or different, will be better than us. As I've described, I think that's very likely. It'd be disappointing if it weren't. They'll live longer, they'll be smarter, and they will be more empowered than we are. And so we can't, because they'll outsmart us, but also because we shouldn't, because they'll be able to make wiser decisions than we can. But we shouldn't try to micromanage their future. I think the idea of laying down programs, laying down laws that bind future generations is misguided in detail. I mean, we should let them run. Let the development of the ecology of mind occur organically, and hope for the best, because that's all we can do. Okay. So with that, I'll end this one and take questions. Thank you. Oh, I have the microphone, of course.
Okay, thanks very much, Frank. So I'd like to open the session for questions, both from the audience who are here in this room as well as on Zoom. So if you have any questions on Zoom, please enter them into the chat. I'll start with a question myself, as I do, which is that many years ago, our hero Richard Feynman gave a rather visionary after-dinner talk called "There's Plenty of Room at the Bottom," in which he foresaw a world in which we would have tiny machines that were bigger than atoms, but really very small. And well, that's a kind of vision that maybe hasn't been fully realized. Do you have any comments about the prospects for that?
Well, no, it hasn't been fully realized, but it was remarkably well realized. I think this was back in 1959, I think the original talk, when computers were still based on vacuum tubes and filled whole rooms and were not very effective. So Feynman's idea that you could store information on atomic scales was way ahead of its time. And so in many respects, the vision that he put forward there not only was fulfilled, but overfulfilled. I mean, he talked about the challenge of putting the Encyclopedia Britannica on the head of a pin. That's child's play now. We can do that. He talked about the challenge of making motors that, I forget the exact specifications, but also sort of pin size. And nowadays we make molecular motors. So many of the aspects of what he proposed have been not only fulfilled, but overfulfilled. But some of them haven't. I think the main one that hasn't is one that he didn't really articulate very well either, which is, I think is extraordinarily important, and I've emphasized, which is the technology of self-replication with variation, which I think is has extraordinarily potential for enabling some of these grand projects, but also less grand projects, just things like the possibility of cleaning up the atmosphere by engineering creatures, little bacteria-like creatures or actual bacteria or algae that soak up the carbon dioxide, put them out in the ocean. So that, but also if you want to think about terraforming Mars or exploring the galaxy, or sending out missions to the whole galaxy, though that technology is something for the future. Or if you want to build giant brains, turn whole mountains or turn whole planets into giant computer farms or more organic looking brains, then that's the technology. So I would say there was indeed plenty of room at the bottom. You could summarize that great talk in a very simple observation that you make over and over again, that Feynman made over and over again, which is that atoms are very, very small. Atoms are very, very, very small. And so in objects that are extremely tiny on human scales, you can store and manipulate enormous amounts of information. That is a commonplace today, but back in 1959 was not something that many people were thinking about or had fully internalized. And I'm not sure even Feynman realized how much, how delicate a touch we'd be able to develop on that scale. It's changed the world. Yeah. I'll repeat the question. Go ahead. To preserve. Yes. Okay. So the question is, I mentioned this idea of making quote spores unquote that would retain the knowledge of humanity, not only the abstract knowledge, but also maybe, you know, samples of valuable products, samples of genetic codes of useful things, maybe including humans for that matter. What should that be? Well, that's a research project. It's a very interesting question. What should the forms of these spores be? Where would you put them? What would be the directions for using them? These are very interesting research questions. I don't have the answer off the top of my head, but it's something that I think deserves really careful thought and doing it. So people make things like time capsules, but those are very crude. There are seed repositories. We could do better, and we should do better. Yeah. So if there's some wealthy person who doesn't know what to do with their money, that would be a worthy project, I think, to fund. Yeah. Okay, I'll ask another. There's another one. Other questions on the web too?
Thank you. So I guess I'll do, it's one question and then a follow-up with it. So at the on the very last slide, you put children in quotations. And I'm curious if when you think about what our children will be, if you're thinking not just our like physical offspring, but also these other kinds of minds that we're helping to create. And the follow-up question to that is if that includes those children too, do you have any concerns about the fact that there'll come to a point where these artificial minds might, given what they've learned from our own history, believe that they're better than us humans? And at what point, like, do we start to consider like our actual children versus our creations?
Coming up for your follow-up.
So basically the question is, will actual humans in their current form or something close to their current form, maybe wearing eye watches and interacting with computers and maybe with some modest genetic enhancements to make them smarter and longer lived, and so whether those will continue to play a big role in the at the vanguard of mind. Well, I think yes, humans are beautifully adapted to the Earth's biosphere, and I think the kinds of more general children we're talking about don't use the same kind of resources. And so I don't think there's necessarily room for need for conflict. Also, these kind of mind children will not have monsters from the id. They won't have arisen from a brutal process of natural selection. And it's a challenge, of course, to make sure that they don't have nasty habits and that their motivations are benign. But so far, but I'm optimistic about that, with one exception, which is a very important exception. There are artificial minds or synthetic minds being constructed for military applications, whose reason for being is to be sensitive to threats and to react aggressively to them. And that's really dangerous, especially if there's a lot of secrecy involved, because then by definition, people don't, there are people or other intelligences that don't understand them by design. So that's got to be very carefully monitored. But otherwise, I think I don't see any reason. Maybe I'm naive. Well, I am naive, but I don't see a clear reason why synthetic intelligence should be anything but cooperative and helpful and look fondly upon us, just as we generally look fondly upon our parents and emulate them in some ways, usually, or sometimes, ideally. So again, I think this is a case where humility is definitely in order. It's our ability to predict the behavior of these complex objects is very limited for fundamental as well as practical reasons. Things could go wrong, but I don't see clear or even very plausible reasons to think they will go wrong. So care is certainly in order, but not paralyzing fear. So, yeah.
So there's a question from Betsy. We'll check. Devine. She says, is it a problem that human skills get replaced by machine supplementation? For example, when GPS replaces map reading and trip planning.
When. Well, yes. So the question is whether our skills are becoming obsolete. And yes, some skills are becoming obsolete. Other skills are becoming enhanced. This is not a new process. Plato famously complained that reading and writing was a really bad idea because it degraded the process of memorizing things, which was a very valuable skill, important in training minds and a virtue. You mentioned GPS. I think that's a very happy example where GPS has taken the fear out of exploring, certainly in the sense of exploring cities that you might visit or your local neighborhood, and you can only get lost up to a certain extent if you have a reliable GPS. You can go out into the forest and wander and not have to worry too much about getting back. Yes, it does degrade or potentially degrades map reading skills, but in fact, I think that's not true. Certainly when I use GPS, it's often through Google Maps, which requires skills. It's different skills than reading the kinds of maps you see in atlases or but close enough. I think that there's much more gain than lost. You know? And
do we have another question?
And of course, yeah. Oh, okay. So here's a question. What do you think technologies like ChatGPT will have on education, teaching-wise and learning-wise? Well, they remove some skills and or they make some skills less valuable and enhance other ones. So they make the skill of producing crude texts less valuable. They enhance the value of enhancing crude texts to bring them up to a high level of perfection. They also, I think, will greatly enhance the process of searching for information, because you can converse with the search engine in a much more natural way and ask more detailed questions, and it will be more fruitful. It's more powerful. Now, there has to be a process of adjustment, because homework assignments based on writing essays, for instance, are going to be testing at a different level. Okay. If you want to test for superficial knowledge of a subject based on an essay, you can't do it. If you want to test for deep knowledge, well, then you have to be ingenious about asking the right kinds of questions that ChatGPT won't answer appropriately, or just look for higher levels of insight in the work that's submitted. So there'll be an adjustment process, but it won't be the first time that people have had to adjust their expectations based on what technologies makes easy and difficult. I read, by the way, probably many of you saw a column by Tom Friedman about ChatGPT, which was way over the top. And the cynical thing that occurred to me is that it'll put Tom Friedman out of business because it can produce analysis at that level very quick and very easily. Yeah. Yeah.
I'm sure you're familiar with the Fermi paradox. Essentially, it raises the question of where is everyone in the universe? There's lots of interesting resolutions to it. One that's interesting to me is that advanced civilizations tend to destabilize due to perhaps some technological discovery. So I was wondering what you think about that with regards to things like synthetic minds, artificial intelligence minds, and our ability or wisdoms in managing these complex systems. In particular, for example, I'd like to point out that today ChatGPT accidentally released private information about users and the questions that had been input in the system in the last couple of months. And Sam Altman put a comment out saying that that was an accident and to forgive them. But it's kind of haunting because that is the question at hand. So I'm curious how you think about it.
Okay, so the question has several parts. Let's first talk about the Fermi paradox, which is that if you extrapolate our technological civilization and its visibility from different parts of the galaxy, also its ability to see things from different parts of the galaxy, say, Fermi found it surprising that we haven't seen anything or been contacted by intelligent life. So there are many, many possible resolutions to this paradox. One is that technological civilizations might be rare. I don't think it's plausible that life is rare based on how quickly it emerged on Earth once the conditions were at all not prohibitive. And based on now we know that there are many Earth-like planets in the galaxy, many, 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 many Earth-like planets in the galaxy, including some not terribly far away. But the emergence of intelligence capable of producing civilization and sort of making themselves visible, that's much less clear how common that is, and was very contingent here on Earth, and only has happened in the last 200 years. That's one possibility. Another. So that's certainly probably the simplest answer. The other aspect of it that you touched on is that the length of time that a technological civilization puts out signals might be quite brief. So if you're looking for such things, you're looking for sort of a signal that is localized not only in space but in time, and that makes it very much harder to imagine, to find. And that short life could in turn be due to two things. One is that there's an instability associated with high technologies. That could be, but I don't find it particularly plausible. I think, especially if we pay attention to making spores and pay attention to taming monsters of the id, I think there's every prospect that human civilization will flourish, and the technological civilization will flourish. And another possibility, though, that I think is more plausible, is that the technological civilization might go quiet, especially if it's based on quantum technologies that work best in peace at low temperature. They may not want to build out Dyson spheres or things that are very visible from a big distance. And so, our civilization at present would be very dimly visible from only small parts of the galaxy that had extremely sensitive detectors. And it could be that the signatures never get big, never really get big. So that's fine. It also is possible that an advanced civilization, but partly because it wants to be left alone, wouldn't want to put out signals that are visible. There's many potential solutions to this paradox. All of them are speculative. Probably several of them are true. Yeah.
Another question. Do you have a question?
My question is, are we really moving towards a utopia in your opinion? And if yes, then will humans take us there? Will humans take us there, or will it be other forms of intelligence?
So I'd like to think that what we're headed for is an ecology of minds that will contain many different kinds of minds that will thrive together. I'm not sure I would want to call that utopia, but it's because utopia means nowhere. It's going to happen. I'm very optimistic that it will happen. Its detailed contours are very unclear, but the emerging understanding and power that I've sketched for you, to me, makes that the most plausible future. If we can manage to dodge some nasty but hopefully temporary hurdles.
Well, we're almost out of time, so there's one question from the Zoom audience. This is by Shashank Arokar, who asks, in a future age of extremely tiny but smart machines, so these would be almost invisibly small, would we be able to protect our bodies and our privacy?
It won't be easy, but yes. And actually, this is a problem that's already occurred and has been solved to a limited extent, but it gives you an idea of the challenge as well as how it has been met. Namely, our bodies are subject to an onslaught of tiny but smart machines known as microbes and yeast and viruses. And we have a very, very elaborate, sophisticated immune system that protects us from that, I think, will be an analogy, some kind of immune system that probably won't, well, almost certainly won't resemble in detail our immune system, but may, in its guiding principles, resemble our immune system. Will address the same kind of problem that our immune system addresses. I should say that although I didn't mention it in the life lecture, the immune system is another beautiful example of self-reproduction with variation. Because our immune system has to build from a relatively small repertoire, our initial repertoire, the ability to recognize lots of bacteria that we might be exposed to and mount big counter onslaughts to their presence. And the way it does that is to learn their structure and learn to recognize them, and then to reproduce many cells that recognize them, and then latch onto them and kill them.
So that's all we have time for. Thank you, Frank, for another thought-provoking and stimulating talk. And thanks to the audience for participating. We have one final lecture that'll be 6 o'clock on next Wednesday. So see you then. Bye-bye.